Hey, what's up, guys? So let's solve this very stupid Leetcode problem called 231 power of 2. So given integer n, it return true if it's power of 2, otherwise it return false. Right, so basically, integer is a power of 2 if there is this x such that n is 2 to the x. And this 1 is true, 16 true, 3 is false. Okay. Right, so the simple, you might need to use the binary representation, right? But this is actually what we need. So basically, we can just do this simple trick that n and n minus 1, right? So basically, for example, if n is 8, right? If you write 1, 0, 0, 0, right? If you n minus 1, it becomes 7. It becomes 0, 1, 1, 1, right? So if you do the end, it becomes 0, 0, 0, 0, right? So if you can prove that the n is power of 2, then it must look like 1, right? And then if you end, it becomes 1, right? So if you do this, then it becomes 0. Okay, so that means this is the condition, and you need to return the n is not 0, and the n cannot be 0. Okay, so this is the answer. So yeah, basically, if n is power of 2, then you can prove it's 0, and then you can prove that if this is 0, then n is power of 2. I think the reason is very simple, right? Let's try to prove it. Suppose n into binary representation look like n1. Yeah, I mean, let's say nk, right? And then you can try to ask what is the -1 change, and since you require it to be 0, right? So you require it to be 0. So and the n1 must be 1, right? So this guy must be 1, right? Because this is the leading coefficient, right? So so which means that each term must be the difference of original, right? So this guy must be minus negative nk, right? Okay, and there's a possibility, right? So if this is 1, right, but -1 must be let's say this guy's n is 0, right? So that means this term must be 0, right? This guy term must be 0, and right. So let's see how I can see this. Right, so this term must be 0, right? So if you end this 1 and right, so so every time you -1, then you will lost this guy must be 0, right? So this means that all of these terms must all be 0, right? All of these terms must all be 0, right? Otherwise, that if there is a remaining term, you -1, that term will decrease, right? So this guy will remain 1, right? So you can prove that if n and n -1 0, then your n must be written as 1, 0, 0, 0, 0, something which must be power of 2. Okay. Yeah, so who should we prove that if n is power of 2, then this guy is 0. If this guy is 0, then n is power of 2. Okay, that's it. See you guys next video.